Hi, I'm Russ, and welcome to this video. I recently read a biography about Albert Einstein, and he once said, "Imagination is more important than knowledge. For knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution." Today, I'll be providing knowledge in how to build solutions using ASAs, and the hope is to spark your imaginations on building awesome blockchain solutions. In order to understand the SDK code I'm about to show, let me review the life cycle of an ASA. Then we'll show you how to create an NFT visually, as well as an imaginative solution using NFTs. The lifecycle for assets on Algorand consists of the following steps. Creation. An asset is created by any type of account on the Algorand network, including smart contracts. Optionally, configure account roles for manager, reserve, clawback, and freeze. We looked at both asset creation and asset configuration in the intro to ASA video. Transfer. Assets can be transferred from one account to another on the network. The receiver must opt in first to prevent spam. Freeze. Assets can be frozen to prevent transactions. A freeze asset transaction allows accounts to temporarily freeze assets in order to prevent them from being transferred or used. Redemption. Assets redeemed for their underlying value through clawback. A clawback asset transaction allows an asset issuer to recover tokens from a specific address. Destruction. Assets can be destroyed. This transaction must be issued by the asset manager while the creator holds all of the asset's tokens. All right, let's take a look at some demos here and take a look at how to do all of these functions through the SDKs. Then we're going to create your own NFT using Algorand. And then finally, we're going to take a look at non-fungible domains. Very cool solution. Okay, we're going to go ahead and take a look at creating an ASA, configuring it, opting in, transacting, freezing, and destroying the asset. So the entire life cycle we'll take a look at here. The first call you see here is going to go ahead and do an asset configuration. This is going to create the asset. We have all the parameters provided here with the values. These accounts were restored using passphrases for testing purposes only. Production apps should integrate with a wallet to do the signing. We're going to go ahead and take account 1 that we've restored. You see down here this N7G account. That's going to be the sender or creator of this particular asset. We're going to do a total of 1,000 of these. We're going to set the default frozen property to false. And then also we're going to give it a unit name and an asset name. And we are going to assign the manager, reserve, freeze, and clawback functions to the second account. And then we have a URL as well as a decimal point, and we're going to use 0 decimals on this. And then we'll go ahead and sign that and then go ahead and broadcast the transaction. So you can see the output down below. There we have the clawback address being sent to the second account. The creator address on this is going to be that N7G account that we looked at. And then you can see all the other parameters here that we specified for asset creation. And down below, you can see the asset ID that returns back from the code, as well as the amount, the asset ID, and whether the isFrozen flag is true or false. So next up is the change manager function. We are going to configure the manager account is going to be set to the first account that you can see here. The other accounts will still remain as the second account that we have in our list. And currently, the second account is the manager that we set up initially. So that's the account that needs to sign the transaction. So here is the output down below. You can see now that the manager account is also N7G, which is the same as the creator. So mission accomplished there. And all of the other management functions for clawback, freeze, and reserve are still set to the VPX account. Next, we're going to use the asset transfer transaction method. We are going to opt in account 3. So this means that the sender is going to be account 3, the receiver is going to be account 3, and we're simply going to send an amount of 0. And we're always going to be passing in the asset ID as part of all of these calls now. Okay, now you can see the asset ID withholding. You're going to have the amount is going to be 0, and this is for the account that has just opted in. And then next we have the asset transfer transaction again, and we're going to have the amount this time is going to be sent to 10. So we're going to send 10 from the creator account to account number 3. And you can see the results of that down below. So now we have an amount of 10 in account 3. The next call we're going to make is to the asset freeze transaction method, and this is going to freeze the state to true. And now you can see down below where we have the is frozen field is now set to true. And next we're going to also use the asset transfer transaction, but this time we're going to use this to do a clawback. And the way this works is this must be signed by the asset's clawback address. And we can see that we are signing this by account number 2, which is the one that has that particular function. So what we're going to do here is we're going to claw back 10 from the account that we sent it to, and it's going to go back to where it originally came from. And that would be the receiver account of account number 1. Now you can see the results down below from that. The account that had 10 now has 0, and the account that originally was restored now has 1,000 back in there again. So now that the account creator has all of the tokens in its account, we can go ahead and destroy that. And we're going to use the asset config transaction to do that with. So here you can see the transaction was successful, and you can see down below that this asset is destroyed. Okay, let's take a look at Algorand.io. So you can see I have an NFT collection here. The way we do this is go ahead and just hit the mint button. ARC stands for Algorand Request for Comments. ARCs provide standards to the Algorand community. ARC3 is more useful when handling a large amount of metadata like videos or other formats. Use the QR code link tree at the end for more information about other ARCs. So I'm going to go ahead and give this a name of Russ Festino, Profile 7. The unit name is a shorter name, 8-character max. We'll call that Russ 7. Well, let's go ahead and give this a description as well. And then you have the ability to give it some properties. Any additional metadata is stored on IPFS, but the ASA is created on Algorand with a link to IPFS. And then we're going to go ahead and upload the file. So there you can see the image we're going to upload, and now we're going to mint it. So we're going to upload to IPFS first, and now I'm getting a confirmation on my cell phone to confirm there is a successful transaction. And now you can see this has been added down below. Let's take a look at one more tool. This is NFD, or Non-Fungible Domains. A non-fungible domain allows a unique readable name for an Algorand account. And if I look at my gallery, lo and behold, there is the new one that we just put in here. And the way this works is you can mint your own NFD, your domain, and then let's do a search. And there it comes up, and you can see for 92 algos, you can buy that domain, and then you can refer to it as just your domain.algo.xyz, just like I put in rust.algo.xyz. In summary, we took a look at the lifecycle of Algorand assets and demonstrated that through the SDKs. Finally, there are many ecosystem tools for creating assets. We took a look at Algorand.io to create an NFT, as well as non-fungible domains. There's a QR code here for resources, including a link to the deck. Thank you very much for watching this video.